So basically, this is the formula for you to calculate an amount of output. All right. So Q is represent output, where capital plus labor plus raw material. For capital, it's more toward fixed input, where labor and raw material is considered into variable input category, where this kind of input will decide how much output we're going to be in a production. There are two types of input. There are fixed input and variable input. As you can see, fixed input is constant. Fixed input never change as increase or decrease amount of production. Meanwhile, for the variable input, it will change or it will increase as the product as in increasing in production. Okay, there are example of fixed input like machinery, land, building. Meanwhile, this is an example for variable input. So when we talk about short run and long run period, it tell you the time required for fixed input to convert into variable input. It's mean that in order to convert fixed input into variable input from the short run, they have to wait until a long run period of time in order to convert all input into variable inputs. Why? Because variable input are more flexible in order to increase more production. So they also need required more time in order to plan or to convert all of this fixed input to another more flexible input like variable input. Please remember, in short run, there are two types of input. There are fixed input and variable input. This is for the short run production function, where labor represent a variable input, meanwhile capital is represent for the fixed input. This is for short run. Meanwhile, for the long run, all input will be variable input, as I just mentioned before. Law of diminishing marginal returns tells you that when the amount of output being increased by time to time in the short run, where the amount of input we have fixed and variable input, because of the fixed input is in constant level, the amount of output in a short run production will going to be decreased until certain level, because of the fixed input cannot change in order to cater the increasing number of output in order to increase more the amount of production. So as you can see here, this is the table shows that the increasing number of capital in fixed input is constant. As I just mentioned to you, in a short run, there are two types of input, which is fixed input and variable input. Fixed input never been influenced by the number of production or output. So meanwhile, the more output being produced, the more variable input will increase, so based on the total production over here. So this is marginal product and average product based on the previous formula that you have seen. So there are three stages of short run production function, where it tells you different situation in short run production function. This is how you calculate or measure the amount of marginal product by by subtract 54 with the previous number of total product and divide by the difference between labor or variable input, which is 9 to 8. Then you can get the additional production increase in production in 2, -2. It shows that it decreased in 2 because of the law of diminishing of return. So how about the average product, where the number of product divide by the number of labor variable input. to know that every labor produce how much production. It shows that one labor produce 7 output. Okay, based on the previous slide where you see the table shows that 3 stage of short run production. Meanwhile, in this slide, it shows you the 3 stage of short run production function in graph graph figure, right? So for the first stage, where the amount of total production increase, so what happened to the marginal production? Marginal production will be increased as the average production also, which represent by the purple color over here. So how it end in the stage 1? Stage 1 will end the moment marginal production equal to the average production. This is the end for stage 1. What happened in stage 1 in production actually? So in stage 1, production is called inefficient. Why? Because the number of outputs still considered as small. At the same time, plant and machine, which are fixed input, have a big capacity. It shows to it tells you that in the stage 1, the amount of production didn't come to the maximum production yet. So it is considered as inefficient because you are considered as produced in small quantity. That happened, for example, gardenia. So before the MCO being imposed, the amount of gardenia bread production is at a normal level where they are not fully utilize all of their capacity. Alright, so that is an example. So what happened in stage 2? Stage 2 start when the maximum average production equal to the marginal production. This is where they start. Okay, after that the marginal production will be going to decrease as the average production increase. At the same time, total production still increase but in a small rate lah. So stage 2 and where the total production meets the maximum point. This is your maximum point. What happened to the what happened to the marginal production? Marginal production will reach 0 point by the end of stage 2. What happened in the stage 2? In the stage 2, the production is considered as the most efficient production operation ever done by the firm, which means that in the stage 2, production is the most efficient, the most better compared to other stage. Why? Because they utilize all of the firm capacity until the maximum production. So what happened in the stage 3? In the stage 3 is where the law of diminishing return happen. Why? Because the more additional labor being used or being added, the number of total production will be lower because of law of diminishing return. Why? Because of law of diminishing return, it tells you because the fixed input never change, which means that it's like gardenia when it comes to the MCO PKP, they cannot produce more in order to meet the higher demand, increasing demand in the market, because the factory and they plant only can the most maximum level they can produce at this level only. So if they try to increase more of their stuff of level, so it will become inefficient because the amount of capacity already meet the maximum, they cannot produce more anymore. So the more they increase their level of input, it will become a waste of resources. That is the reason why production decrease. Okay, we already just finished discuss about the short run production. So now we are going to go into the long run production function. Okay, what is mean by isoquant analysis? Isoquant is referred to the possible combination of two factor inputs which give the same level of output. Okay, it tells you in the long run production function, all variable already become a all input already become a variable input. Like I just mentioned to you before, in the short run, your input will consist of two types of input, which are fixed input and variable input. But when it comes to long run production function, your fixed input already being converted into variable inputs. Why? Because the firm want to increase more of the capacity. Fixed input is constant, cannot change. So they will try to convert the fixed input to variable inputs in order to make it more flexible to increase more of the production. In the long run, that's why they're using an isoquant analysis. What is isoquant analysis? When all input become variable input, the combination between these two variable input will create some level of output of total production. So it means that the production become more flexible compared to the short run production, which is consists only with fixed input and variable input. This is what is mean by isoquant table. Okay, you see, capital supposed to be fixed input, label supposed to be variable input. But this kind of situation where we have variable input and fixed inputs only refer to short run production function. But right now we are talking about long run. When it comes to long run production function, capital input that originally refer as fixed input already being converted into variable input. Okay, remember when long run production, fixed input will be converted into variable input in order to make the production become more flexible. So that is the reason why you see capital can be in 1, 2, 3, 4, 5 because it becomes flexible and variable. If in short run, it will be constant 1, 1, 1, 1, 1 here, one number only. So because of the two inputs becomes variable, your production function will be flexible. You can choose any type of output you want based on the combination between labor and capital because both of it already become flexible. This is what they call a long run production. This is what they call an isoquant curve. In other words, is isoquant graph lah. When you measure every output in our isoquant table, you will find the graph will be shaped like this. Okay, there are four characteristics of isoquant graph where it must be downward from the left to the right. So when it moves to the right, it shows that the number of output is more higher, getting more higher. So it won't intersect between each other because if you can see here, it it didn't show any intersection. It doesn't mean any intersection because isoquant is shaped both based on the point over here to here and to here. In here there is no such thing as a point, it's just a normal intersection, but it didn't give any value because in isoquant curve, intersection will never happen. You see, this is the isoquant map, which tells you the more when the curve of isoquant move toward the right side, the more right it goes, the more higher the quantity of output being produced in a long run production function. Okay, how to understand more about increasing return to scale based on the previous slide, the increasing return to scale will indicated by the increasing number of output more than the percentage increasing number of input. If you can see here, this is output. Okay, from here to the right side, when they move to the right side, it shows that the output is increasing from isoquant 20 to isoquant 16. We call it isoquant because it is long-term production. Okay, it is not short-term, this is long-term. So the increasing number of output is more than 100%. Meanwhile, the input only 100%. Which one is more higher, input or output? You see here, capital increase 100%, labor 100%. Meanwhile, output, this is output, more than 100%. This is input, this is also input. Okay, output, percentage of output increase more higher than percentage increase in input will indicate increasing return to scale, which means that the, the output will be bigger, increasing in output will be bigger than increasing in output. What happened to the constant return to scale? Okay, constant return to scale tells you that the percentage increase in output is similar to the the percentage increasing number of input here, over here. This is input. Okay, this is output, which means that 100% increase in output because of 100% increase in input. Or another example, 60% increase in output because of 60% increase in input. Alright, capital and labor ni input. Okay, isoquant is output. So because of the input and output percentage increase is similar or same, it considered as constant return to scale. Decreasing return to scale. Alright, if increasing return to scale indicate when output percentage increase much more bigger than increase in percentage in input, and when it comes to constant, output percentage is similar with percentage in increase in input. Meanwhile, for the decreasing return to scale shows that the percentage increasing in output much more lower than percentage increase in input, which means that the percentage increase in input much more higher than the percentage increase in output. It tells you that your input are much more bigger than the increasing number of output lah. That is the reason why they said the increasing number return to scale.